First of all, let me be the first to thank you all for taking some time to jump on and be able to listen a little bit around our first or one of our inaugural NetScaler and Red Hat OpenShift webinars. So I'm your host. I'm John Gibson. I'm going to be your MC for today, asking all the questions and introducing a couple of our speakers that we are going to have on for today's information. Today, we're going to be talking about high performance and secure ingress with NetScaler for OpenShift applications. Again, my name is John Gibson. I'm going to be your MC. I'm joined by three lovely folks that I have the pleasure of working with on a regular basis. Cameron Skidmore, Global Partner Solutions Architect here at Red Hat. Kamal Bardwaj, Director of Product Management for NetScaler. And Meyer Patil, Lead Product Manager for NetScaler. So let's talk a little bit around the agenda. What are we going to be talking about today? So we got a few topics that we're going to be going through and also a live demonstration. We're going to be talking about choosing the right Kubernetes platform and Ingress, why NetScaler for OpenShift, the power of one, NetScaler Ingress controller, containerized Ingress proxy with NetScaler CPX. And then we're going to dive into the NetScaler OpenShift integration, some use cases for you, as well as sharing the live demonstration on those use cases. Last but not least, we'll talk a little bit around benefits of NetScaler and Red Hat integrations with some key takeaways, and we'll dive right into the Q&A portion of this. So just to get you guys started off, we wanted to kick off with a quote by Gartner. By 2027, more than 90% of global organizations will be running containerized applications in production, which is a significant increase from fewer than 45% in 2022. So we're really excited about this, especially here at Red Hat, because as you guys are going to see, OpenShift is our key solution into the containerized infrastructure environment. And really, we're really excited about this because we believe that this is the next iteration in modern infrastructure. And we have a wonderful partner like Citrix and NetScaler that we can bring along with us into this. So Cam, without further ado, if you want to talk a little bit around OpenShift from Red Hat.
Yeah, let's get into it. I'm going to give a brief overview of first the why. Why would you want to think about OpenShift in the first place at all? Then I'm going to go into the architectural breakdown of what OpenShift is, hopefully dispel some common misconceptions. Maybe even the people who are very familiar with OpenShift may learn a thing or two. And then we will start to go into why NetScaler and OpenShift are such a strong pairing as well. So these are three main use cases for OpenShift. Now you can dice this up differently than how I presented it here. You could go and subdivide these categories even if you wanted to. But in the hope of simplicity, we'll break it into modernized traditional applications, create new cloud native microservices, and then if you want to really advance your data analytics and AI and ML approach, this is also a very strong candidate to do that. One thing that comes to mind immediately here that's changed a little bit more recently is the really strengthening of OpenShift virtualization. And so that will kind of fall into the first tier here, the modernized traditional apps. With OpenShift virtualization as it is, you can migrate your virtual machines into OpenShift and use OpenShift as the control plane for both the virtual machines that are your legacy applications and new applications that you're containerizing, or maybe you are modernizing the existing VMs and slowly want to make sure that you're testing along the way and not doing everything at once. Some people have hundreds, thousands, tens of thousands of traditional applications. It will make sense to modernize a lot of those into containers, though it probably won't make sense to modernize all of them into containers. Some VMs will always be VMs. And OpenShift allows for that flexibility in a really, really robust way. I don't know that there's that many other solutions out there, if any, that can have such a strong centralized control plane for both virtual machines at this point, as well as containers. Another part of that, when it comes to OpenShift and kind of the differentiation, of course, OpenShift is a Kubernetes platform, and we'll get into that into more detail in a moment. But when it comes to Kubernetes platforms that can really present a hybrid cloud solution, so across different cloud providers, and you're on premises hardware and cloud environments as well, OpenShift is really at the forefront of that in many different aspects. One of the benefits of having a Kubernetes-based, container-based infrastructure for your applications is the advent of microservices and the flexibility that that creates. A lot of people think of microservices, rightfully so, as breaking up different components of an application into more simple building blocks, but there's a lot of other benefits baked into that as well. Benefits of access management for those different portions, benefits of figuring out where the bottlenecks are in compute resources, and even being able to make sure that certain networking is established along those microservices communications, which we'll allude to a bit more in a second. Data analytics and AI and machine learning. I think everybody's probably heard AI and machine learning 12 times a day since ChatGPT came out, maybe 20 times a day now. But OpenShift has a robust set of tools for really starting you out on your AI ML journey. We have a ton of products coming out of the open source community and AI ML models coming out of the open source community that we're really driving home. We really see this as the new frontier of open source, where open source revolutionized Linux OSs and then Kubernetes. We see AI ML being the next real innovations in open source, and we are definitely excited to be a part of that. All right, John, let's get to the next, or whomever is driving. Okay, here's my OpenShift architecture slide, at least at a high level, right? I'm going to go from the bottom here. I'm going to work my way up. I'm happy to answer any questions after this, of course, as well. The big thing about OpenShift, and it goes beyond even what we have here in the gray bar at the bottom, is the agnostic way in which it can run. Whether it's on bare metal, virtual machines, your own cloud, a public cloud, any of the public clouds, or even at the edge. And we have special deployments of OpenShift that have a much smaller footprint that can be run on the edge to extend out your posture, your cloud native posture, all the way into that region, which is rapidly expanding. OpenShift is consistent across that. It really is a very strong, if not the strongest, abstraction layer for running your applications in that way. Now, working our way up the stack here, of course, operating systems one up from the hardware here. It always will be. And that's where we have really staked our claim over the last 30 years or so, and it's no different now. Red Hat Enterprise Linux Core OS is what we use, and that has a bunch of optimized features for running containers in and of themselves, and chiefly also security features baked into it so that you can securely deploy no matter where you are. Okay, so here's where some of the confusion sometimes happens when it comes to OpenShift. A lot of times people think of OpenShift as OpenShift or Kubernetes. That doesn't happen as much anymore. I've been talking about this for 4 years now. When I first did, people were always confusing the two. But OpenShift is Kubernetes, right? Red Hat's one of the top 2 maybe, contributors to the Kubernetes open source project. We've been one of the first ones to be involved. Every day we're contributing code into the Kubernetes project, and we are building OpenShift, which is really a collection of services and operators on top of Kubernetes into that every day. A lot of the really early developments in Kubernetes were contributed by the Red Hat developers in the open source community. It's one of the reasons why, if you've ever messed around with OpenShift, and I think this is still the case in even the newer versions, but the CLI has a little bit of differences when it comes to Kubernetes, like project. That is for when project preceded what the equivalents were in the kubectl. Moving up from Kubernetes from there, of course, we're making sure that we're deploying stable supported versions of Kubernetes, but we have a ton. These are nowhere near representative of everything that comes with and is supported by OpenShift these days. But everything from multi-cluster management, cluster security, global registries, data-driven insights, you have your graphical user interface, you have telemetry, you have CI/CD pipelines with Argo. You have so many different tools that actually make Kubernetes worth it, honestly, to get the most out of all of your teams, whether they're networking teams, security teams, developers, and ops chiefly. Cloud native is cool and all, but it really doesn't matter unless you're making your engineers and developers' lives easier and more productive, and these are the tools that actually make it so. Of course, beyond this even, we have a massive partner ecosystem around OpenShift. Part of the reason we're here today, right, to talk about NetScaler. But it goes well beyond the scope of Red Hat in and of itself. It really is a village effort, and the fruits of that are something that we're all very proud of at Red Hat Partner Ecosystem. John, or sorry, I think Kamal might be driving. Whoever's driving me. Yeah, thank you. This is a point I wanted to touch on because it's an important development, though not entirely new at this point. So OpenShift is a first-party offering on AWS, Azure, and IBM Cloud at this point. That's a really big deal. That means that it is jointly supported by both the AWS engineers, Red Hat engineers, and same with Microsoft. This is a really, really strong way to make your OpenShift infrastructure inclusive of your committed spend. It is a really strong way to try out OpenShift, even with the simplicity of deploying it, simplicity of the support of it, and creating elasticity of your cloud native deployments, which is a huge, huge, huge contributor to the value of it for organizations. That ability to scale as demand increases and then scale back down. It's really what makes the cloud and hybrid cloud particularly an economical interest for most companies to pursue. And of course, our certified solutions, like the NetScaler solution, also are supported and work alongside these first-party offerings as well. All right, next slide, please. Okay, NetScaler and OpenShift. I'm going to tee this up for my colleagues who will then be talking about this in more detail. But a few big things to note here. One is that this is a completely certified solution on OpenShift and Red Hat Enterprise Linux, of course, but chiefly we're talking OpenShift today. That means the deployment of it as operators, which is, think of it as human logic for the deployment of the software to run continuously in the cloud native environment. That is certified and tested by our engineers, NetScaler engineers, to make sure that it works, and that if there is anything wrong with that, you can open a ticket, and we will take that ticket and we will support that solution in its deployment through the operator. A big aspect to leverage here is the L7 functionalities that NetScaler is going to allow you to leverage into the OpenShift environments. If you are familiar with NetScaler already, this is going to make you feel pretty much at home. A lot of the cloud native networking capabilities that Kubernetes takes advantage of, that OpenShift takes advantage of, NetScaler has really integrated beautifully with and is taking advantage of. So I think if you're a NetScaler engineer, you would be able to pick up and understand exactly what the value is here from a day-to-day. Outside of that, I'll call out the NetScaler Global Server Load Balancer, and that it is also part of this holistic solution as well for making sure that you're routing traffic. Of course, you're in the cloud, you could be anywhere with these deployments, and the GSLB is going to allow you to make sure you're effectively routing and failing over where it makes sense to globally, if that is, of course, your scope. And that kind of brings home, again, the value of a product like NetScaler that's going to make sure that while your applications are being ephemerally spun up and down in containers in a OpenShift or Kubernetes environment, that NetScaler is going to be able to effectively route those existing and new containers to the consumers that are trying to leverage them, whether they be internal or external to your organization. We have a bunch of blogs and documentation as well. If you want to go into the weeds, we encourage you to do that. But for now, I think I've run out of time on my segment. So Kamal, I think I'll toss it over to you.
Okay. Thank you, Cameron. It's always good to hear our partners and our customers talk about NetScaler more. Hello, everyone. I'm Komal Bhardwaj. I'm a part of the NetScaler product management team. I have been with the NetScaler for over 6 years now, and have been in the cloud native, Kubernetes, and OpenShift team, and in this ecosystem for that long. And it has been a pleasure working with the OpenShift team. There are several customers who use NetScaler with OpenShift, and it's been really a great journey to see how, like back in 2018-19 timeframe, when this whole ecosystem was starting up, and now we are seeing really high mission critical applications running with NetScaler on OpenShift. So with that, let me get into some details. Well, the first thing is that we're going to be sponsoring Red Hat Summit and Civil Fest that is happening in early May this year. So if you are planning to be in Red Hat Summit, or if your colleagues, if your team members are going to be there in Denver, Colorado, it will be good to chat with you on the Citrix and NetScaler booth. It will be good to see how your progress is with NetScaler, with OpenShift, and with Ansible as well. So we'll be happy to talk to you then. Well, so let me start with NetScaler. As Cameron had talked about the full stack of offerings that OpenShift provides. NetScaler has been a part of the uh, application delivery framework for well over 2 decades now, and it has established itself as one of the frontier ADCs, application delivery controllers. Uh, so the key capabilities that NetScaler brings to the table are load balancing, TLS termination, AAA, web application firewall, layer 7, layer 4 routing, uh, configuring the incoming and outgoing traffic. And this is where NetScaler really shines. Customers have loved NetScaler for this very reason, that it gives so many flexibilities to uh, route and to secure the incoming traffic, either from for your public applications or for your private applications, which may or may not be running on the Citrix environment. But NetScaler has been a rock solid application delivery controller for several years now. So this is powered by our one-pass architecture, in which we open the packet once, and then based on the policies configured by the administrators, we do all these functions and then route the traffic to the backend applications. And we do the same for the response. So these core capabilities have placed NetScaler as one of the leading ADCs. With this, there are other benefits that also come. We have seen that over the past several years, there have been different waves of modernization, right from hardware to virtualization to containerization, and to the edge use cases that Cameron just talked about. NetScaler has been through all these journey, and we have modernized our stack. We started with the hardware form factors, including which were called MPX and STX, which are still used by a lot of customers. And then the virtual form factor VPX, and then in the containerized form factor, we have launched CPX for the last 4 or 5 years, and a lot of customers are using containerized NetScaler inside the OpenShift clusters and other Kubernetes distributions. And recently, we have been working on another cool form factor for NetScaler, which is BLX, which runs as RPM on popular Linux distributions such as RSGL. And we'll be talking about these solutions in a while in detail, and Mayur will be giving a demo. So that's why we'll keep using these acronyms. But high level, all of these are NetScalers only. These are just different form factors of NetScaler. And the third key benefit of NetScaler is that there is a unified control plane. You could be using different form factors for different use cases, for different applications, for different regions, for different subpart of your organization, or if you've made some acquisition, then they may be bringing in some other form factor of NetScaler. But you can control the overall life cycle of all of these NetScalers using a simplified and a unified control plane, which is NetScaler Console. It used to be called as NetScaler ADM, Application Delivery Management, but this is a single-stop solution for you to manage all your NetScalers. Okay, so the main use cases that NetScaler serves for OpenShift are these four, and we have seen that the customer journey starts from the left-hand side, and then it has some of our really advanced customers have started using NetScaler for the rightmost use case, which is multi-cluster ingress. So starting with the first one, where NetScaler is used for routing, securing the incoming traffic to OpenShift clusters, which means that you send the traffic, HTTP, TCP, UDP traffic from your end users, from your employees, or from other applications that might be accessing OpenShift clusters. and then you want to do TLS termination, you want to do web application firewall, or if you want to route it to a particular application inside OpenShift based on some HTTP, TCP parameters. NetScaler does all of these things in a automated, in a certified, in a Kubernetes and an OpenShift friendly way. The second big use case with NetScaler is the automated GSLB configuration. As Cameron was saying, your applications, once they reach production, they'll be deployed in multiple regions, in multiple clouds and hybrid kind of deployments. So you would want to route the DNS traffic to the appropriate region and then take the actual traffic to the backend application. So NetScaler has automation which helps in routing the incoming traffic, incoming DNS traffic to the appropriate region or site based on the health of that particular application in that OpenShift cluster. So this is another very popular use case. And these two use cases have been used in a static manner. But the new thing that we have done, especially with OpenShift, is we have made these automated and we have made these OpenShift friendly. So you'll see the operators, you'll see the verified automation that we have done, which makes these things really work together in a tango. The third use case is East-West proxy, and this is an emerging use case where NetScaler CPX, and we'll talk about that as well in some time, is used to route the inter-microservices communication. So you have application A and application B in OpenShift cluster. You want to do mutual TLS between these two. You want to do authentication. You want to do rate limiting between these two applications so that there is no internal DDoS. So NetScaler CPX can be used to do all this traffic management. And the last thing which we have seen is that in a single region or in a single site, customers are deploying multiple OpenShift clusters, and they want the same load balancer, same EDC in front of these OpenShift clusters. It's the same instance of NetScaler that routes traffic to multiple OpenShift clusters. So your same application for high availability, resiliency region can be deployed in multiple OpenShift clusters, and NetScaler will route traffic to the same application in cluster 1, cluster 2, cluster 3, based on the health of the application and the way you have configured. And the other thing that is becoming very popular with our customers, and where the customers are really getting into a lot of depth, is the integration with the observability tools, which also run on the OpenShift platform. So if you're running Prometheus Grafana stack on OpenShift, or if you're running Kafka clusters on a separate OpenShift cluster, NetScaler can send its metrics, health, metrics, logs, events to these endpoints in a very Kubernetes friendly manner. You can send the health of the applications that the NetScaler is fronting, and also the health of NetScaler instances themselves. With this, I come to an exciting news. We have recently launched a new variant of CPX. CPX is the containerized NetScaler, and the CPX, we were calling it CPX Express. CPX Express can be used in a freely downloadable manner. You can just go to qa.io, which is again another Red Hat product. You can go to QA, download the latest version of CPX, and it will run without any license. The only limit is bandwidth cap of 100 Mbps. You will have all the features of NetScaler in it. It will be having full feature parity with the licensed version of CPX. The only difference is bandwidth, and then the support is through the NetScaler community. We welcome you to join the community.netscaler.com. On that, if you raise any questions about CPX Express, we'll be helping you out. The key benefit of CPX Express is that you will be able to take your production, development, testing applications really fast to production. We see that developers often download the open source version of the proxies, like Nginx HA proxy, and then they develop their application. And then once they are moving it to production, then the IT and the Kubernetes platform team comes and says that, hey, you need to use a licensed version of this. And often there is a lot of disparity between these two. And we wanted to solve that problem by giving developers a really a platform to run fast in the development cycle without worrying about what will happen once this thing reaches the production environment. And the disparity between production and development environments is really low, really less here. So once you develop with CPX Express, the only thing your Kubernetes platform admins and the networking admins have to do is to add a license to the same instance of CPX. There is no difference in the container image of CPX Express and CPX. So that's where you'll be able to really move fast from development to production. Another interesting thing that we've done is another NetScaler BLX, which is the Linux RPM form factor of NetScaler that is also certified on Red Hat Enterprise Linux. So if you want to use, if you want to run a really heavy duty bare metal server and put RSGL on that, you can put NetScaler BLX on that, and then it will give you all the capabilities of the EDC. NetScaler, all the automation tools that we are developing for NetScaler, such as the Ingress controller or the observability exporter, they are all certified and bundled as a part of one unified NetScaler operator, and we'll do a quick demo based on it. And this helps you in being confident that the automation that you'll use on OpenShift is verified, validated, tested by NetScaler and Red Hat engineers. Well, this is one of the most frequently asked questions that we run into, and I wanted to take some time to discuss this. We get asked by several customers that why should you choose NetScaler over the other options available, such as F5 or Nginx or HA Proxy. And we keep seeing a new open source version of ADCs, load balancers, every 3 or 4 years. So I wanted to take on the answer of this in two major sections. One is, what will your cloud architect or Kubernetes platform architect think? He or she may be concerned about the overall architecture and the long-term performance of the OpenShift applications. And then the second section is about the day-to-day affairs of how you will roll out a specific feature for an application, or how you will keep the lights on from an observability perspective. So the first thing is that NetScaler is the only ADC in the market that allows you to prevent a sprawl of data plane and control plane elements. So if you're using F5, Nginx, HA Proxy, we're going to use different images, different flavors, different way in which you are configuring the reverse proxy or the ADC. With NetScaler, it's the same experience. Same experience if you're using an external load balancer or an internal Ingress proxy. The way you configure, the way you secure these proxies, the way you download the images, the way you license these is absolutely homogeneous. So once you standardize on NetScaler, you do not have to go to any other proxy to serve your ADC needs. On the control plane side as well. So if you're using F5 or Nginx, then there are multiple control plane elements as well. It is big IQ, or it is Nginx 1, or it's Nginx controller. With HA Proxy, it also comes with its own control plane. So then you are also going to manage multiple control planes. So it's turtles all the way down. We help you reduce that. We help you have only one control plane for all the load balancers. It's important. And because then all the ADCs that you're using can be licensed using the same control plane. You can manage the upgrade lifecycle of all the ADCs. You can also make sure that if there are CVEs, then those are upgraded properly through that. So you don't have to manage the control planes as well, which helps in reducing the operational overhead for your networking and OpenShift platform teams, which is a big deal because everyone is really excited in the beginning, but from day one onwards, you really want efficient operations to be done. On the performance side, we have done comparison with F5, Big IP, and Nginx about two critical factors. One is the throughput and the latency, how many HTTP TCP requests we are able to serve, and what is the latency introduced by the reverse proxy as well. And in those instances also, we have really shined. We've shared a link here that compares the performance of NetScaler and the other available proxies in the market. Now, coming to core features, one of the most important features that the customers love with NetScaler is Ingress for non-HTTP application. So if you have a message bus, or if you have some connected devices, or we have got some large automotive companies who are using NetScaler to ingress for their connected cars, for their IoT devices, etc. So this helps in using the standard ingress for HTTP and non-HTTP applications. Another exciting thing that customers like from a feature perspective is the cloud-like experience for on-prem. So in public cloud, you typically say service type LB, and the public cloud load balancing layer will provision a VIP on the public cloud load balancers. That experience of public cloud is copied over on the on-prem version, where you give a free pool of IP addresses to the NetScaler IPAM, and whenever you want to launch a new application, NetScaler will pick up that IP from that free pool and then associate that to the VIP on which the traffic will land from either applications or the end users. Because there is, and the last point is, because there is a multitude of reverse proxies that customers use, we have standardized on observability. We have integrated with most of the popular observability platforms, and either if you are using NetScaler VM or NetScaler Container, all of these send the metrics logs in a unified format to these endpoints. Moving on, just wanted to show you how all these things come together. We work with several customers. One of the large multinational technology companies in the US, they wanted to migrate from OpenStack to OpenShift, and there was a problem of real sprawl of tools and infrastructure. And when NetScaler and OpenShift came together, they were able to really reap the benefits, and now their applications are going faster to production. So this is how the architecture stack looked like before OpenShift and NetScaler. They were using the HA proxy load balancer in front of Tanzu clusters, and they were using another control plane console for service discovery. And the customers were really unhappy about multiple control planes, multiple reverse proxies. The same capability has to be done on HA proxy and then inside the HTTP router in the Tanzu as well. So it was sort of not helpful for the customer to manage this and also to observe what is happening with the end user traffic. Now the customer has standardized on NetScaler OpenShift and NetScaler and OpenShift, and they're using one NetScaler, which is NetScaler VPX on hardware for managing the incoming traffic and leveraging the heavy duty SSL performance on the NetScaler SDX, and then that traffic gets routed to several OpenShift clusters. All are behaving in unison, and the NetScaler CPX is the ingress in all of these OpenShift clusters, and this has helped them standardize in terms of observability, in terms of configuration, in terms of security policies, etc. So this is where all of these things come together, and you are able to take day one to day n operations really managed smoothly. Well, now I want to come to a live demo section where we'll show how these things are working on OpenShift platform. So the first use case that we're going to talk about is the most simplest one, where you will use the existing NetScalers. It could be NetScaler VPX, the VM form factor, or the BLX, which is the RPM form factor, in front of your OpenShift applications. So the essential element is the Ingress controller here, which will run inside the OpenShift cluster. It will coordinate with the OpenShift API server, and then it will understand what is happening inside the OpenShift cluster and keep configuring the high performance ADC in front of the OpenShift cluster. And typically, this is how the structure is, where the networking team will have a NetScaler, and the platform team will be managing OpenShift cluster. They just need to come together and put the Ingress controller inside the OpenShift cluster, which will help in securing the applications from from the web application firewall kind of threats. They will be able to do bot management, etc. All these policies will be applied on the external load balancer. And in fact, Kubernetes also recommends that you have an external load balancer to do all these major functions. So this is the first architecture that we will talk about. And then we will talk about the second architecture, which is a sophistication and a development over the first one only. The essential thing that has come here is the NetScaler CPX, which runs inside the OpenShift cluster. And this helps you in delegating responsibilities. So the external load balancer will be typically managed by the networking team, where you will have the L4 policies or the enterprise-wide security policies. And then you will give a CPX typically to individual application teams, so that these teams do not have to reach out to the external load balancing team for every request. So if there are some layer 7 policies that they want to apply at a local level, they can apply it on CPX. So for example, you can do a wildcard domain offload on the external load balancer and a specific domain offload on the internal load balancer. If you want to, let's say, if your application's behavior has changed because you want to route the application traffic to a particular container based on HTTP parameters like cookies or the path, etc., and you want, and this behavior keeps changing, let's say every 2 months, then you don't need to reach out to the external load balancing team for that. Keep those policies on the CPX so that is sitting very closely to the applications, and you can move faster there only. Okay. So with this, I want to hand it over to Mayur, who will do the demo of these use cases that I was just talking about. Mayur, I hope you have enough time. Thank you.
Yeah. Thank you, Komal, for telling us the NetScaler capabilities. And now I will tell you how these capabilities are implemented from this live demo. So with that, I am Mayur Patil. I am from NetScaler product management team. We'll be giving the demo on the 4 use cases. First use case is on how do you load balance the sample HTTP application through the BLX. And here we will see that this application is HTTP based, so you need the secure access to the application out from the outside OpenShift cluster. To do that, we will have a SSL offload functionality presented on the BLX, and then we'll also demonstrate how we can do the authentication for this application through the BLX. So with that, I'm just now onto my OpenShift console, and from OpenShift console, I'm going to demonstrate how we will deploy the Ingress controller, and then we'll also deploy the Ingress. This is my BLX. The OpenShift and BLX both are hosted on AWS, and as you see, like this is up and running. For the demonstration, I'm going to use my how-to guide. This guide will be available to you after this demo. And I'm going to follow the steps which are written here, so that once you take this back and try it out, setup, you will have those handy. So let's get started. So under workload, what I've done, the containerized monolithic application, it is HTTP application, is already running. Now to expose this application outside over internet, we need 2 components. One is NetScaler Ingress controller. So this will be the management plane pod running inside the OpenShift cluster, configuring your BLX. So let's go to the operator. And in the operator, we have a NetScaler operator, what Komal has introduced, Cameron has introduced earlier. So here is my NetScaler operator. Let's go to NetScaler operator, and there is an option to deploy the NetScaler Ingress controller. So here, once you click on that, you will get an option to fill this YAML file. You will need to add the specific details of what is your BLX IP. And then what are the details like the secret. For example, you have a NetScaler which is sitting in front of the OpenShift cluster. You need to provide the login credentials, so that will be passed from the secret, which will be deployed inside the OpenShift cluster. So with that, let me just create the Ingress controller. So now, as you can see, it is getting deployed, and in some time it will get deployed. Now you can see it has been deployed. Now, as I was referring, we need to deploy a Ingress. With that, we will be configuring the BLX, and we will be exposing this application to the internet. So let me copy this file and just show you here. So this is my Ingress file. And in this Ingress file, we provide the parameters like what will be my endpoint on which internet users will be accessing this application, and what is my domain. In this case, as you see, this is my domain through which I will be accessing this application, and this is my actual application, which is running on the HTTP. So let me just copy this this Ingress kind from here, go to the console, OpenShift console, then go to the networking ingresses. As you see, there are no ingresses. Let me just come here, deploy the Ingress, and to create. Okay, so as you see, Ingress has been created. Now, let me just refresh it. As you see, right, application was not there earlier. I am just accessing that domain, and I can see that application is available. This application is coming with a Redis database. So that's how you can able to access the stored entries as well. To continuing the first demo itself, where I was mentioning, we will also demonstrate how we can do the basic authentication for this application. So for that, we use the concept of the CRD. And in this CRD, we will be creating the authentication CRD instance. So this is my basic authentication that I will be applying from the OpenShift through the CRD concept to my BLX instance. So this is our NetScaler CRD that we have created. I will just change this configuration, which I have copied from the getting started guide. And now let me come to this application. Now, once I refresh this page, you will see that credential pop-up has come. This is because the basic authentication which I have applied, if I just let's say try to give the wrong entries and the wrong credentials, it will not accept unless I provide the right credentials. So this demonstrates my first use case of how BLX can do SSL offload and basic authentication for your application. Moving to the second use case. In this use case is building on top of the first use case, and we will be kind of doing the two interesting use cases here. First, where the applications which are running inside the OpenShift cluster will be doing the SSL encryption on the application domain. However, the multiple applications can be residing in the same OpenShift cluster with a single, let's say, Ingress proxy. So in that case, you need a wildcard domain hosted on the external proxy. In this case, BLX will do the wildcard domain SSL re-encryption, and the CPX, which is inside the OpenShift cluster, will do the application domain specific SSL re-encryption. So this sample app, NSCN app, is SSL based HTTPS. It needs end-to-end TLS. So in this demonstration, you will see that from user, we will do the re-encryption at the BLX level and at the CPX level. Followed by, we will also have one use case where we will block the non-trusted, untrusted clients with our rewrite responder policy. So let's move to the use case 2. And in this use case, let me just first deploy that application. So here is my application manifest file. So first, let me just copy this deployment from here, go to the deployment section, and then just create a deployment. So now I'm creating a sample SSL application. For that application to be exposed, we also need a service kind. So that we will also go to workload, and then under networking, there is a services section. Let's go here and create the service. So now we have deployed sample SSL application into the OpenShift environment. For time purpose, what I have done, I have already created the CPX from the same NetScaler operator, which is running here. So now, since CPX is also deployed through operator, we will now expose this application to the internet with the two levels of ingress. First level of ingress is for exposing this application to the CPX. So this is the manifest file for it. As I was mentioning, in the CPX, you will have application-specific domain re-encryption. So I will be having this application-specific SSL certificate hosted on the CPX through this file. So let me just copy this ingress from here and go to the ingress section and do create ingress. Just to reiterate, with this ingress, we have exposed this application to the CPX in the same OpenShift cluster with a application specific domain. Now let me go to the next section where we will now take the ingress, which will actually expose this application outside the OpenShift cluster through the CPX. So if you see, this is my CPX service, which will be the backend for my BLX. And this is the IP on which this SSL application will be exposed. And if you notice, the host is the wildcard domain name that we are providing here. So now let's copy this also from here, go to ingress section again, and click on the ingress. So now what I have done, I have just created the ingress, and now let me try to access this application. Wow. You can see the magic. As soon as I applied the ingress, you could see that application is up and running. So the Netscaler ingress controller is so efficient and comes into the management plane performance, so that it just understands the API events which are happening and applies the necessary steps on the BLX. I was also mentioning that we'll also demonstrate a use case of how do we allow or deny, allow listed or deny listed clients. So for that, we will also use the concept of the CRD again. And here we are using the rewrite responder policy. So in this rewrite responder policy, we will be blocking the clients which falls under this list. So let me just copy this policy, which is rewrite responder policy, and I will search for my rewrite responder policy under the CRD instances, and I will now create the rewrite responder. So now this rewrite responder policy has been applied, and now if I try to access, I will get this message because I have added my IP to that list. If I just remove that again from this list, I will again able to access this application. So as you can see, right, like this concludes the second use case where you have seen how we can do end-to-end SSL. How in the first use case you have seen how we can do SSL offload with the combination of the security use cases. So you can have a NetScaler deployed for your workload in any combination or for any deployment that is preferred by you. In the third use case, I want to talk about the applications which are getting scaled across the different clusters. So here comes the concept of the multi-cluster ingress. In the multi-cluster ingress, you will be sharing the external proxy resources. So in this case, you will see that the IP is actually shared between the application which are residing into different clusters. So for that demonstration, what I have done, I have an application which is running into the default project. And let me just show you the workload here in the deployment. As you can see, there is one application running, and this is my another OpenShift cluster. And in that OpenShift cluster, there is another application running. So if I just try to access that application, you can see right on .252 /red is coming from one cluster, and same application is also accessible from another cluster. For a demonstration, I have kept the separate container images, but at the end, the idea is that with the multi-cluster solution of NetScaler, you will able to deploy your application across the OpenShift clusters within the data center, and the BLX or any form factor of NetScaler can do the load balancing and traffic management for you. The last use case, which I want to talk about, is from the observability. So NetScaler has a good observability integration. One of them is the Prometheus integration. So across the multi-hybrid cloud deployment, wherever you have a NetScaler, it can integrate with the Prometheus, and Prometheus can scrape the metrics from this BLX, CPX, or in that matter, any other form factor of the NetScaler. So for that, in this demonstration, I just want to tell you how the Prometheus can help you to troubleshoot the application health through the golden signals. So for example, this is my Prometheus Grafana dashboard, which is actually getting the metrics from my NetScaler. And here we are demonstrating how this bandwidth or the error profiles are shown to you. So moving on to the conclusion, I want to emphasize that NetScaler and Red Hat OpenShift together provides you an enterprise-grade solution for your microservice application delivery. With NetScaler, you prevent the tooling sprawl because you have a NetScaler which is running outside the OpenShift cluster, inside the OpenShift cluster, and the OpenShift, which is a leading Kubernetes orchestrator. So with Red Hat and NetScaler together, you get enterprise support, which is very important. And these are the few resources that I want to share. As I committed, I will be sharing you the how to guide. So this QR code is for that how to guide. You can take this with you after this call and try it out. Along with that, these are the several resources on the left-hand side that we have provided to you, including white papers, some VRDs, and some OpenShift deployment specific documentation. Again, I want to repeat that you can meet us on the booth number 124, where we will be there at the Red Hat Summit. Happy to connect with you. And if you have any queries or any POC discussion you would like to have with us, you can reach out to us at the event or before event or after event. We are there for helping.
Can we see the generated configs, parentheses, GUI or CLI in the BLX? Curious.
Yeah, you
Sure.
can see the CLI, the config generated by the Ingress controller on the both the CLI and the UI. So this is the BLX UI on which you can go and be able to see the exact CSV server, LVV servers, service groups that were created by the automation solution, which is the Ingress controller.
And just a quick call out by Harihara. It's great to see you. Please note that the NetScaler BLX in this demo is actually running on top of RHEL 9.x VM on AWS. And just a quick call out that BLX is also certified by Red Hat. So thanks for calling that out. Awesome. Thanks so much, Mayur. Thanks, Kamal. And thanks, Cam, for that. That was fantastic information. So thank you again for joining. We hope to see you again on future webinars and workshops. And again, please come and visit us at the booth during Red Hat Summit if you'll be there in Denver, Colorado, first week in May.